October of last year, the first known object from outside the solar system entered it. It is theorized to have come from a system with two stars. It is called Oumuamua, which means scout in Hawaiian. The sighting of the asteroid allows scientists to predict what future objects will look like. It also gives us info about the composition of objects from outside the solar system. A Space.com article from last month states that Oumuamua is spiraling out of control due to a collision with an object in its original system, but other information is difficult to find. It is fascinating to our group because it is the first object we know of that entered the solar system from outside of it, which shows that it is not only possible but probable that it could happen in the future and makes it easier to study objects from other systems. This object doesn't necessarily prove that planets could enter the solar system, as it would be unlikely that they would be pushed out of their system. It does prove, though, that objects such as asteroids and black holes could enter the system with the right conditions.
Alright, so here we can see that Mamo comes in approximately August 12th or so, a little bit before the picture got a little cut off. And it goes through our solar system, past all the inner planets' orbits, and doesn't clash with any of them, but it gets relatively close over here to Mercury and Venus, and then it goes straight past Earth, like a good minute away from it, so we're good, we don't have to worry about it hitting us. And then it leaves around October 28th or so. It doesn't stay there for that long.
In late 2014, over 300 million light years away from our solar system, X-rays rocketed across space to reach us. A black hole, sitting relatively dormant, had been encountered by a passing star, and the star was beginning to be devoured. The ordeal produced a jet from the center of the black hole. The jet that the black hole produced is the first by a supermassive black hole that we've seen. Another article by MIT News has a similar description but makes it clear that the jet is proportional to the star it's consuming. This proves that the star being consumed is causing the jet to be the size that it is, and gives further evidence to the theory that the black hole jets occur when feeding is ongoing. We find this interesting because it's an image from so far away that gives us more info about black holes. It specifically gives more info about black hole jets and their origins. Black holes are still relatively unknown, but any information helps in the desperate push to understand them.
Alright, so in this picture you can see what it would look like if it were to be animated, how the black hole ate the star, and then it projects it out as a jet, which is the blue stream, and that's about it. And this, as you can see here, guys, is just what it would look like if you saw it in a picture or a telescope or something.
The planet being studied here is WASP 39b. The planet is 700 light years from Earth. It has some similarities to the planet Saturn. The article was about how the Hubble Space Telescope was able to study and get a lot of information from the exoplanet WASP 39b and found out many new things about the planet, such as info about the atmosphere and how it orbits. The change in atmosphere shows how the planet has migrated significantly and it has moved way closer to its sun. It is fascinating to our group because it is an exoplanet and very little is known about exoplanets as a whole within the universe. The new atmosphere that has been studied has shown to be very different from the atmospheres of the planets in our solar system.
As you can see in this picture, which is different from the last one, it's still WASP 39b, but it has different colors in it because it doesn't have the sun like throwing off the shading and such, so you can see it's Saturn-like colorization.
Jupiter's background consists of bright and powerful winds. NASA's main goal is to determine the framework of Jupiter's atmosphere. Scientists are trying to determine how the winds in Jupiter can affect the motion and temperature of the planet. The article is fascinating because it explores Jupiter's past, and our group is really interested in the composition of the planet. The measure of Jupiter's gravitational field can be used to further answer planetary dynamics in the future.
Taking a closer look at Jupiter's Great Red Spot, it's one of its biggest wonders, and it's a storm, a very massive storm of about 1,200 miles long and 700 miles wide, which makes it about 2 to 3 times larger than Earth. And its atmosphere consists of around 425 mile per hour winds, which would make it uninhabitable. In the fifth article that we found, it discussed the discovery of dark matter, and it talks about a large 7-ton machine called the Alpha Magnetic Spectrometer that, although almost didn't make it to space, makes a huge discovery. The machine is designed to pick out particles in space and sort of file them out and list their charge and composition and such. And with that, the discovery of dark matter would be found, and we were able to better understand it by studying it, because it would lead to many more discoveries, since more than 90% of our universe is made up of it.